Hello and welcome to another video. In this video we're going to be working on longest common subsequence. And in the problem you're given two strings, text1 and text2, and you want to return the length of their longest common subsequence. If there's no common subsequence, return 0. A subsequence is a string generated from the original string with some characters can be none deleted without changing the relative order of the remaining characters. For example, ace is a subsequence of A, B, C, D, E. A common subsequence of two strings is a subsequence that is common to both strings. So here we have an example where this is string 1 and string 2, and so ace would be the common subsequence. In the second example, they're the same, so just the whole string. And in the third example, there's nothing. So in these problems where you can remove characters from either one of these, this is going to be a DP problem because basically you have the choice for each character, do I remove it or do I include it? And you can only include characters that are actually part of the longest consecutive subsequence. So let's make two arrays of some strings and let's kind of show how this would work. So we'll have two of these, and these are going to be our two strings, and we'll just say they're the same length for simplicity. So let's just say we have a string like A, B, C. In fact, instead of using characters, we'll just use numbers. It'll be the same thing, right? We'll compare numbers for equality, and it's going to be the exact same thing with strings. So we'll just say like 1, 2, 1, 3, 4, 5, 6, 1, 7, 1. And second we'll have like 1, 3, 1, 5, 4, 5, 6, 5, 5, 5, let's say. And this is going to be the exact same thing with strings or characters. You're basically just checking for equality. So what you basically need to do is you're going to start at the start of both of these. So you're going to start here and here. And you'll have a couple of cases, right? Because you are allowed to delete characters. If the characters are exactly the same, then that's a match. And then you would move both of these down. So let's actually use arrows to make it easier. So let's draw one here and draw one here. So if the characters are exactly the same and this is a match, then this should be like one of the characters that you're using. And then you will recurse and you'll move both of these down, right, to check the next character. And if the characters are a match again, you do the same thing. You just have like 1 plus recurring both. But if they're not a match, like in this case, then basically you have to say, I have to move on one of these or the other one. Because you can't take both of these characters, right? So you have to recurse in some way to get to the end. So you're going to say, like, let me try to recurse this way and see what happens, right? Where I just, like, say, I'm not including this character at all. And maybe this character will still be useful. Or I will recurse the other way, where I'm going to recurse this way, where I'm not including this character at all. And you basically do both of those, right? Those are your two choices. You either don't include this character or don't include this character. That you don't want to recurse both because one of these might be useful. Because like let's say this is a 2. So if you just skip both, then you're going to skip this section right here, right? Where like this is a match, but you would have skipped that if you would have just recursed down both of them. So that's kind of the idea. Whenever there's a match, you're going to recurse down both of them, but whenever there isn't, you're going to try one and the other and see what gives you the longest possible string. So that's kind of the idea. And so let's actually write down like the memoization for this. So memoization needs 3 things. So it needs a state, base case, and recursive case. Oh, and by the way, also, well, I guess we'll talk about that in the state and base case and things. So for the state, it's pretty easy from this little picture, right? So you just need like an index of the first one and index of the second one where we're at. And this is fine because you always want to look at the constraints. So the constraints here are 1,000 characters. So that's totally fine because like 1,000 times 1,000 is going to pass. Now the base case is kind of obvious too. So the base case is basically just whenever one of these arrows is out of bounds, right? Whenever you have no more characters in one of these strings, you can't have any more common characters. So base case, whenever I or j is out of bounds. And the recursive case, so like I said, there's going to be two recursive cases basically here. One matching character, in which case you just say 1 plus dp of I plus 1 and j plus 1, right? You just recurse down both. And the second case is mismatch. Then you just take the maximum of recursing down both, right? So maximum of dp I plus 1, j stays the same, or dp I and then j plus 1. So it's going to be one of these two, and then basically you just keep adding these, and you just have a recursive case with the cache, and this will be fine. So that's kind of how you do this. Yeah. And that's basically, for any of these problems with strings where you're trying to get as many common characters as possible, you just have to know that you want to take the greedy solution of whenever there's a match, just take that immediately. You never want to like skip any one of those. Once you know that, I think the rest of it is like pretty straightforward. So we can code that. So we can just say like cache, or what you could do if with kind of like newer Python syntax is you can actually do this in a DP function, and then this will cache the results for you instead of having a cache. So you don't have to check, like if it's in the cache, it will basically add caching to your function. So you can do this. So we can say def DP, and we have an I and a j. And so we can check for a base case. So if I equals length of text1, or j equals length of text2, that means we're out of bounds in one of the strings. That means we can't like have any more matching characters. So we want to return 0 here. Now we want to check, do these characters match? So if text1 I equals text2 that means these characters match. So we just want to return, remember we don't have to cache anymore, that this will handle the caching for us. We can just return 1 plus dp of recursing down each of these. So 1 plus dp of I plus 1, j plus 1, right? We're taking both characters and just recursing down to the next one for both those. Otherwise, we want to return the maximum of recurring down both of them, right? Skipping one or skipping the other. So this will be max of dp I plus 1, j, or dp of I, j plus 1. And now we just have to call this function, and we want to start at index 0 and index 0 to go through all the characters. So we can return dp of 0, 0. So let's try this. Looks like we got an error. Let's see. So unsupported operands for int and none type. So it looks like we have a none type here somewhere. Oh, it's because we didn't return here, so we want to return. Okay, there we go. And there we go. And it should pass. So you can see it does pass, but it's kind of slow. And that's because this is memoization. So the way to do it faster is going to be with bottom up, because then you don't have to have, like bottom up is just naturally going to have a faster runtime. And also we can get rid of one of these dimensions. So if you just wanted the memoization solution, you can skip this part and maybe go to the end for the, or actually let's just do time complexity for this now. So we can just say the time here is O of the length of both of these strings, right? So like m times n, and these are constant time. Oh, we also have this print. That's why it's also so slow. Okay, that's definitely going to make it a lot slower. And the space is O of m by n as well, because we have this cache, and you can have m by n different combinations here. So if we actually try to run this now without this print statement, this should be significantly faster. So there we go. It is significantly faster, but it's still not great. And that's because, like I said, this is memoization, so a true bottom-up DP would be faster. So the next part we're going to do is, and like I said, if you want to just stop at memoization, it's totally fine. But if you have practiced bottom-up DP, if you want to see a much more performant solution that saves space, that's what we're going to do now. So basically what we're going to do is we are going to figure out the things we need and like what's the base case. And so the base case, we can actually leave this up to refer to. So you can see the base case is when we're out of bounds. So essentially we're going to have an array that's like m by n, and the base case is going to be when we're out of bounds on either of these things. And that's going to be our, so if I can quickly draw that. Let's say we have something like this, and we have something really easy. So let's just have something really easy. Let's say we have this, and we'll have something like this. And ideally, you want to be able to like not have to visualize it. You want to just kind of know the pattern and do it, because that'll be a lot faster. Let's say we have like ABC as one word and DEF as the other word. So this is going to be the out of bounds part, right? So this is going to be all zeros, and this is going to be the out of bounds part. So this is going to be all zeros. So we're going to start with this initialized, and we're going to work our way up to right over here, right? The 0 element. So the base case is being out of bounds here should all be zeros, and being out of bounds here should all be zeros. And what we're going to do is, because every row relies on the row below it, as you can see here, right? we're basically going either one to the right or one down. Every row relies on the row below it. Like to get these values, they only rely on values in this row or the row below it. We're just going to have a template for storing 2 rows, and we'll get rid of a dimension. So first things first, in my personal preference, I like to get rid of the row. So because we're going to have an m by n, the row is going to be the first one of these. And because ideally you want to get rid of the longer string in your space, we want our text1 to be longer than text2. So we can start with if text1 is not longer than text2, if it's shorter than text2, we'll just swap them around. Just because this is like my personal preference of doing it. Because I want to have, like, I think it's nice to have consistency when you do these, and then it's going to be a lot faster to do it. So text1 and text2 will just be swapped. Okay. Now what we're going to do is we're going to make our initial row. Like I said, don't want to rely too much on this picture, but basically this is going to be our initial row where we're out of bounds on text1. So this will be text1, this will be text2. Actually, sorry, our initial row will be, we're out of bounds on, no, okay. This is text1, this is text2, yeah, because this is the dimension we're getting rid of. So we're going to be out of bounds on text1, this is the row we want. And so every single row is going to be the length of text2 plus 1 because we want this out of bounds part. So we're going to do that here. So we're going to say dp equals 0 times length of text2 plus 1, right? We want it to be 1 extra space. Okay, now we are going to have our 2D loop because this is still a 2D, this is still a 2-dimensional dynamic programming problem, so that's what we're going to do. So our first dimension will be the row, which will be text1, and then our second dimension will be text2. So we're going to say for row in range, and once again, quickly referring to the picture, the rows we want to look for are this row up to here. So we need to figure out how long this is, right? So this is basically just length of text1 minus 1 all the way to 0. So that's what we're going to have here. So length of text1 minus 1, and then we're just going to go backwards. And same thing for the column. So for column in range, same thing here, right? We don't need to fill these out because these will always be 0. So we need to fill out all of these for this here, which will just be like starting at this index, and this index will be length of text2 minus 1. So this is going to be length of text2 minus 1, and this will just be like this. Now, for every single one of these, we have to create a new row. So every time we're on a new row, we need to create that row. So we'll just create that row, and then we'll fill it out. So we'll say new dp equals 0 times length of dp. It's going to be, they're all the same length, they're all this length, so we can just use this. Now, the rest of it is pretty simple. We basically look at our things in the memoization. So the two things we have to check for are the letters equal? So let's do that first. So let's check if the letters are equal. So if text1, row 1, remember the row is going to be like what letter we are in text1, and then the column will be where we are in text2. So if text1 row equals text2 column, then what do we want? So if these two are equal, then we want the result over here, right? We want the result of this one increasing by 1 and this one increasing by 1, which is over here. So remember, the thing we're currently on is the new dp, and the thing below it is the dp. So if we're on this index, if we're on this row and this column, we want this column, and there are no more rows, right? The row is the dp we're on. So we basically want the old dp at column plus 1 there. So we can just say new dp at column equals 1 plus dp at column plus 1. Because the value we want to recurse to is this, and then the 1 is just the same as here. So the conditions are basically the same as your memoization. You just have to draw this out beforehand. Otherwise, you have to check both directions. So still new dp column. Now, what are our both directions? So our both directions, let's say we're here. This is new dp. One of the directions is you go to the next letter in word 2, which is new dp at column plus 1. And the other one is you go to the next letter at word 1, which is dp at the same column. So we just get the max out of those. So we're going to say new dp column equals max of new dp column plus 1. That needs to be array index and dp of column. Then finally, when we complete our row, so like let's say we complete this whole row, now what's going to happen here is we're going to say dp is going to be equal to this. And then when we go for this row, then we'll make new dp up here, complete it, make dp equal to this, make new dp over here, complete it, make dp equal to this. And then finally at the very end, your dp will be this array, and this is the element you want. So we're going to say dp equals new dp at the bottom. You can probably fill this out in place, but I found this is a lot more helpful, just making the new row every time. And the O time and space will be the same. So I think this is an easier template to use for all your problems. But in some problems, you can reuse this whole array. It's just a lot more confusing in my opinion. So I like this template a lot better. So finally, we want to return dp at index 0. And we can now comment out all of this because we don't need it. But you can see kind of like the recursive case here is the same. Like all these conditions in here are the same, except now instead of recursing, you just figure out like where in the array am I going. And this is a lot more performant because now we basically got rid of this dimension. So instead of storing a 2D matrix, we're only storing 2 consecutive rows. So we're storing these 2 rows, then we're storing these 2 rows, then these 2 rows, we're only storing 2 rows at a time. And yeah. And you can see it's like a lot faster. So if this is, so once again, to briefly go over it, the reason we did this is because the dimension we're getting rid of is text1. So if text1, let's say, is like 1,000 characters, and this is 4 characters, we really want to make sure that we get rid of like this huge dimension, right? Kind of like if you have a rectangle and you can get rid of, you know, if you only need to store 2 rows of a rectangle or columns, you want to make sure you figure out which one is like way bigger and store the other one. So that's going to help there. And then finally, we just do a normal 2D DP where we just store 2 rows. And this is going to be very common for space optimized bottom up. So if this is confusing, you can draw the whole grid to begin with if you want to. I'm practicing trying to skip the whole grid and honestly trying to skip these pictures because I think ideally I want to be able to get this, you know, let's say in 5 to 10 minutes, and then I want to be able to go from this to this in 5 to 10 minutes. I don't want to take like 40 minutes. So I think actually visualizing it kind of hurts you, like trying to draw it out and visualize it. You more try to want to figure out like what's your base case and just rely on a template that's consistent. And then if your template's consistent and you don't make any mistakes, then you're just going to have like the right outputs, even if you can't quite visualize every single recursive case. I think that's going to be a lot easier. Yeah, so here the time is still n squared because we still do have like we're looping through every row and column, but now our space is O of min of m and n because we got rid of the bigger dimension. So this is going to be a lot more performant, as you can see. So even though our time technically in O complexity is the same, it's faster in practice because you're using an array instead of like a dictionary of tuples. And also, so Python does have a dictionary of tuples. A lot of other languages don't handle this super well. So you have to use like a 2D array or something as a cache, which is, you know, I mean, you can, but like this is just going to be in practice. Even though the time complexity is actually the same, in practice, this is going to run a lot faster. So yeah, and I do think if you get an interview and you get asked something like this, and you can code up something like this, like I think that would be like super impressive. So if you do want to work on more complicated DP, this is good. And I'll also link the video in like more description how to go from here to here if you want to watch that. But yeah, that's going to be all for this one. So hopefully you enjoyed it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.